this set of problems you're looking to evaluate each expression. So you just perform the operations. 4 squared is 16 times 3, which gives you 48. For question 2, when you divide exponents with the same base, you subtract their powers. So this is equal to 5, base 5 to the power of 5 minus the 2. Gives you 5 cubed, which is an overall value of 125. The next one, when you take a power to a power for an exponent, you multiply their powers. So this is equal to base 3 to the 3 times 2, or 3 to the 6th. You can write that out as 729 when you expand it. The next problem here, what you're going to do is calculate inside the grouping symbols first. So you have 2 cubed, which is 8, and 3 squared, which is 9, and you're going to square that whole quantity. So 8 times 9 is 72. 72 squared gives us our overall value of 5184 for our solution. In problem 5, again, we're dividing two exponents with the same base, 3. So we have an unwritten power 1 here. We're going to subtract our powers. So we have base 3 to the 1 minus a negative 4. Becomes, subtracting is equivalent to adding the opposite. So we get 3 to the power of 5, and that is equal to 243. For problem 6, again, we perform the operations here. If you look at these in terms of exponents with the same base, what we have right here, or we can simplify, we have 4 is 2 squared, and we have 3 to the minus 2. In this problem, if we look to put everything in terms of exponents with the same base, we have 4, which can be expressed as 2 squared, 3 to the minus 2, and then that's all over 2 to the minus 2, and 3 to the minus 1. So here we have the two common bases. With the same base, you subtract the power. So we take the base 2 to the 2 minus this negative 2. And then for base 3, we have 3 to the minus 2 minus a negative 1. Subtracting is equivalent to adding the opposite. So when we express this, we get 2 to the 4th times 3 to the minus 1. And simplifying this whole thing, when you take 2 to the 4th, it has a value of 16. And then the 3 to the minus 1 moves that base 3 to the denominator. And that would be your simplified form. And when you look at number 7, we have 24. The negative power is going to move our base negative 2 into the denominator, change the power to a positive. And so when we think about that, 24 does have a perfect power with a base of 2. It is 8 times 3, and 8 is 2 to the 3rd. So what we can do right here for this problem, we just want to create the rational form. The negative power tells us our 24 stays where it is, but this negative 2 base gets moved to the denominator. And if you take negative 2 to the power of 5, you get 32. And it's a negative sign. And then it's just a matter of reducing our fraction. 8 goes into 24 3 times, 8 goes into 32 4 times. Let's move the negative up to the numerator, and negative 3/4 would be our solution. In this last problem, any base to the power of 0 has a value of 1, even if it's a negative number, and so that would be our solution for 8.